Number 2 today, which is actually describing the installation methods. Okay, now see, basically there are two types of installation method. One is full stack and one is pre-existing infrastructure. In full stack automation, OpenShift has a power to provision all the compute, storage, network resources from a cloud or a virtualization provider. And you provide the installer with minimum data like credentials to the cloud provider and the size of the initial cluster. And then the installer will deploy a fully functional OpenShift cluster by itself. So that is the one method. One method is pre-existing infrastructure. Let's say you are using some bare metals, and on the bare metals you are using some hypervisors inside your organizations. Then you can create the VMs for the master node and the worker nodes, and you can use OpenShift installer. Now, so with this method, you configure set of compute, storage and network resources, and the OpenShift installer configures an initial cluster using these resources. And you can use this method to set up an OpenShift cluster using bare metal servers and cloud or the virtualization providers that are not supported by the full stack automation method. Full stack automation is not supported on the bare metal actually. Okay. It is only supporting a cloud or a virtualization provider. Okay. Now, what cloud it supports, you can read on the documentation. Now, when using a pre-existing infrastructure, you must provide all the cluster infrastructure and the resources, including the bootstrap node. You must run the installation program to generate the required configuration files and then run the installation program again to deploy OpenShift cluster on your infrastructure. Now, what does the bootstrap node means? So bootstrap node is actually going to configure a temporary control plane. Okay. And once the temporary control plane has started all the necessary components, so actual control plane would be started. Okay, and the temporary control plane would be deleted. Okay, now whenever you install OpenShift on a pre-existing infrastructure, the first thing which is actually created is etcd. So etcd is the first resource or the first pod which is created inside the cluster. Okay. After that, a temporary control plane will be created. Every information is given over here. At the time of the Red Hat OpenShift Container Platform 4.5 release, the set of cloud providers supported for full stack automation method includes, you can use full stack automation or OpenShift installation on AWS, GCP, Azure, OpenStack platform using the standard Intel architecture x86. And supported virtualization providers and architectures for the full stack automation include VMware, Red Hat Virtualization, IBM Power and IBM Z. And you can see the complete detail over this documentation. Installation OpenShift 4.5. This is the website. Over here you have the complete methods, like on AWS how you can install Azure, GCP, bare metal, IBM Z, Power, OpenStack, RHV, vSphere. These all are supported right now. Okay. After that, now comparing OpenShift installation methods. So obviously certain features of the OpenShift require using full stack automation method. For example, cluster automatic scaling. If you are installing the cluster on a pre-existing infrastructure, this feature you will not get. This feature is only available in the full stack automation method by default. Though you can configure it, okay, once you have set up the OpenShift cluster on the pre-existing infrastructure, clear? But that would be a manual approach. Got it? Now, after that, however, it is expected that the future release might relax such requirements. Now, using the full stack automation method, all nodes of the new cluster run Red Hat Enterprise Linux Core OS, which is the lightweight operating system. And using the pre-existing infrastructure method, worker nodes can be set up using RHEL. But the control plane means master node still requires RHEL Core OS. If you want to download RHEL Core OS, you need subscription. Now, describing the deployment process. So they have given a basic overview, like first the bootstrap machine will be boot up. It will then start hosting the remote resources required for booting the control plane machine. The control plane machines fetch the remote resources from the bootstrap machine and finishes booting. Okay. So once the bootstrap machine actually boots, the master node will be started, and the master node will actually fetch all the resources from the bootstrap machine. And the control plane, which is on the master, it will create an etcd cluster. And with the help of etcd cluster, the bootstrap machine starts a temporary Kubernetes control plane using the newly created etcd cluster. And after that, the temporary control plane schedules the control plane to the control plane machines, and the temporary control plane shuts down. So this temporary control plane is actually started on the bootstrap machine. And after that, it is actually injecting the actual control plane on the control plane machine, which is a master node. And once it is done, the temporary control plane would shut down and yields to the control plane. Now the bootstrap node injects components specific to OpenShift into the control plane, like your scheduler, controller, all the things. And finally, the installer tears down the bootstrap machine. Now, it is not a detailed description actually. If you want a detailed description, you can read it on the documentation. Now, after that, the result of the bootstrapping process is a fully running OpenShift control plane, which includes API server, controller, etcd, and a scheduler. The cluster then downloads and configures the remaining components needed for day-to-day operations via cluster version operator, including the automated creation of compute machines on supported platforms. Now, customizing an OpenShift installation, so you can change the custom resource of cluster operators, you can add new operators, you can define new machine sets. Machine set is a group of machines. Okay, we will discuss it in the 8th chapter. Okay, one chapter is all about machine sets and the machine controller, so we'll discuss this term in the 8th chapter. Now executing troubleshooting commands. Okay, now there are a lot of commands like OC get nodes. It is similar to Kubernetes. OC ADM top nodes. Now this is a new command in OpenShift. With this command, you can actually see the real-time CPU and the memory uses of each node, and how it is getting the data from the Prometheus, okay, which is actually running inside an operator. Now, this is my role.redhat.com, where I can click on this icon to enter the virtual lab environment. Once your lab will be activated, you will see this type of thing. And over here, now my labs are already activated, already created. I can delete them. I can create a new lab. Okay. Let me delete the labs. Okay. It will take a lot of time actually, almost 10 minutes. Okay. You will be having a create button over here. Okay. When you will be getting the credentials from me. Okay. To access the labs. So right now I have already created. So I'm starting it. So there is a bastion system, classroom, master 01, master 2, master C. There is no worker node concept. All the masters are actually treated as the worker node. So OpenShift actually comes with the high availability, multi-master architecture. Okay. So all the master nodes are actually treating as a worker node also. Utility workstation. Workstation is like your machine. So you can do everything from the workstation. Okay. So you'll be logged into the master API server from the workstation by some ID passwords, like the way we do in Kubernetes. So let it start.
So Kaushal, hi, Manish this side. So you said that in master itself, the worker node will be used as a worker node, right? We can onboard our containers on the same node, right?
Yes.
So what exactly, how much resources they are consumed by the master resources?
How much resources are consumed by the master?
Master, whatever the master is mandatory services required to run some containers, right?
4 services: API server, scheduler, etcd, controller.
That I'm saying. So how much is consuming that resources in single server?
In single server, how much resource it is consuming? You can see that by top command, no?
Okay.
Generally, if you want to install OpenShift cluster, these 3 masters needs at least 16 GB of memory and 4 virtual CPUs.
Okay.
That is the minimum requirement.
Okay, so we can see by using that command, right? We can see.
Yeah, by this command you can see the real-time CPU and the memory uses of each node. Okay,
Right,
OC ADM top.
We will see the demo, right, for that command of that node.
Yeah, I'm just opening my labs. So on the workstation, I'm getting logged in. Open web console. This is the complete cluster, okay, which is already set up for you. You can log in on a student by a student password. Now, after that, once you are logged in into it, you need to set up something because this is the workstation, not the master. So you need to log in. So to do that, you have been given a lab, okay, in the end of this chapter. First, I need to run this command lab execute troubleshoot start. You can enable the host paste, and after that you can paste control V. The command will be copied over here. So the OAuth and a lot of things will be prepared by Red Hat itself. So they have given you the pre-defined scripts actually. Okay. All are ready.
So they are also already creating the HT password, everything, right?
Everything. Okay. Now, after that, you need to source this file. Okay. And in this file, actually, all the passwords are stored. Like your Cube ADM password, user password, wildcard, master API server. Okay. And after that, you can run OC login command to log in. OC login -u cube admin. Cube admin is the predefined user. -p, I'm having the passwords for my environment variable. Okay. And after that, I need to give my API server and the port number. That's it. Logged in. OC, who am I? So I'm logged in with cube admin user. This is the command. OC get nodes. There are 3 masters. All are ready. All are treated as worker also. 190 days is the age and this is the version. Okay. OC ADM top nodes. It will give you the real-time data. You can run watch command, watch -n1. And see, this is keep changing. 69, 61 now. 82.
61% is the usage, or what is this means?
61% CPU is being used on master 1. 18% is of CPU is being used on master 2. How much memory it is using on master 2? You have the memory consumption as 3425 MB. Okay. Clear?
Can you explain the CPU percentage? They basically utilization or what? I'm not understand this part.
Utilization of CPU. Okay.
Manish, current consumption.
What are you saying?
Yeah, current consumption of the CPU.
Yeah, current utilization of the CPU. Okay.
No, sorry. I'm again questioning again that this is whatever the CPU allocated for the master 1 master
Manish,
service.
this data is dynamic now. How it can be allocated CPU? Allocated CPU is a static value, no?
That is I'm saying that अगर मास्टर को चलाने के लिए कुछ उसके पॉड्स हैं वो they will consume some vCPU, right?
Total CPU consumption of the master node.
Correct. My point is
correct. कुशल, मनीष का क्वेश्चन है जैसे ETC एक कंटेनर है तो उसके लिए मिनिमम रिक्वायरमेंट कितना है CPU और मेमोरी का? जो कंटेनर है API कंटेनर है,
my question is related to that,
yes,
not
minimum requirement for this container. Yes.
Okay, so you are saying that कि कितना minimum requirement है, okay, to run any pod.
Not pod, but my again, if एक master है, master में आप you are saying that there are more four minimum container that API service, one is etcd and one is okay. There are four containers, right? Need to run as a master services, right, Kaushal?
Yes.
So for that, they will consume some CPU or to run that container, right?
Yes.
So what is that minimum value to run that all the containers for one master?
No, ऐसा कोई minimum value defined नहीं है. Okay. Like it is, if I ask that, what is the minimum memory which is required to run this ping command or the process of this ping command? I cannot say, because inside the container there is some process which is running. I cannot say that what is the minimum requirement of the CPU to run a HTTPD service on the system. Okay.
No, I'm again.
कुशल,
okay. Please,
जैसे कि अभी मनीष ने पूछा था, तो वो छोड़ दो, कंटेनर बेस नहीं, क्या वर्चुअलाइजेशन, तो वो यूटिलाइजेशन पे डिपेंड करता है. अगर मेरे पास अगर 1000 अगर कंटेनर होंगे तो उसके लिए मास्टर में भी ज्यादा कंजम्पशन होगा मेमोरी और सीपीयू का. लेकिन मिनिमम रिक्वायरमेंट फॉर द मास्टर इज 16 GB एंड 4 CPU, करेक्ट?
हाँ, वो मिनिमम रिक्वायरमेंट फॉर द मास्टर है.
ओके. मैं अगर कुछ मेरा प्रोडक्शन है तो मैंने क्या ज्यादा भी दे सकता.
Yeah, you can give it more, but it is not like मैंने मास्टर 2 GB पे भी इंस्टॉल किया है.
ओके. हाँ,
वो
क्योंकि
आपका डिफाइन कर रखा है लिमिट कि आप 4 GB मिनिमम, 16 GB मिनिमम रखो. ओके. बट इफ यू वांट, आप अपने मास्टर पे 2 GB पे भी मास्टर को चला सकते हो, बस आप 2 रिसोर्सेस मत चलाओ.
Right. So I got the answer. Kaushal, you said that 16 GB RAM and 4 vCPU, right?
Yeah, that is the minimum requirement for Red Hat actually.
Okay. So my one I have one bare metal server. Okay, where I that specification is 64 GB RAM and 16 vCPUs. Okay. So I am defining as a master where it consumed by master services is 16 GB RAM and 4 vCPU. So I will have left 48 GB RAM and 12 vCPU, right? That can be used or accommodate as a worker node, right?
Yes, but OpenShift 4.5 only gives you the concept of multi-master architecture. You cannot install the master and the worker differently actually.
I come again the last line where you said.
I'm saying that the OpenShift 4.5 cluster is actually, if you are using a full stack automation, that comes with 3 master. Okay.
That is fine. That is fine. So that should be installed on the different bare metal server, right? So
yes,
that is fine. I understand.
Yeah, on a bare metal, if you have 64 GB of RAM, okay, and you have 16 vCPUs,
yes,
okay, that means आप 4 master बना सकते हो, ठीक है? और
on the same
master
okay,
आप 16 GB RAM allocate कर दो और 4 virtual CPU allocate कर दो.
Okay, so you are saying that as a virtualization we can create a three VM with the or 3 master node, right? On that.
हाँ, तीनों को 16 GB RAM allocate कर दो, तीनों को 4 virtual CPU दे दो, that will be working fine.
Okay, so इसके साथ मैं अगर मेरे resources है तो मैं इसके साथ एक और VM नहीं, that is not a right answer. Yeah.
No, you can create, na, you can have multi-master 4, 5, 6, it depends on you.
Okay, Kaushal, I think ना आप उसके साथ कलेक्ट कर ले हो कि आप you are creating 3 VM on the single server, right? So because I have said that my server has 16 vCPU and for 64 GB RAM capacity, so we can create 3 master VM on that with easily, right? You are saying like that, right?
और 3 अलग अलग bare metal सर्वर है, सब पे 16 GB रैम और 4 वर्चुअल CPU होने चाहिए मिनिमम, तो आप कर सकते हो.
Correct. So rest of the resources will be used as my worker containers, right?
Yes.
Okay.
These are the minimum requirement.
वो usage हम नहीं देख सकते, right? That usage we cannot use. See, that will be specific to hardware KPIs, right?
Yes, that you cannot see. Okay. OCADM top nodes will only show you that उस वर्कर नोड पे अगर आपका 4 वर्चुअल CPU है, then how much is being used.
Right.
Okay. Now, अब अगर आपने वर्चुअल मशीन को 16 की जगह 32 GB रैम प्रोवाइड करी है, तो यहाँ 32 GB का % बताएगा कितना यूज हो रहा है. ठीक है, उससे मतलब नहीं है, उसे मिनिमम 16 चाहिए. Now, उसके बाद you can describe the node same way we have done in Kubernetes. kubectl describe node. Okay. Now, OPC get pod -n OpenShift image registry. Okay, you can see the registry is also running inside an operator. So this is an internal OpenShift registry which is given to you. Okay, जैसे आपका Docker hub है, that is also a registry. Okay, so like that they have given you the internal OpenShift registry. Okay, which is actually going to store your images. Now, so you can see the pod for that also. So OC get inside the Kubernetes you have namespaces. In the OpenShift you have projects. OC get projects less. These all are the projects. Grass, Idea, KubeNode, public system. There are a lot of OpenShift API server. For authentication you have a different project. For cloud credential you have a different project. Lot of projects are there, almost more than 100. Okay. OC get pod -n.
कुशल, वो प्रोजेक्ट ने क्या बाय डिफॉल्ट क्रिएटेड बाय ओपनशिफ्ट?
Yes, all the projects are created by default by OpenShift.
Okay, just you created Grass and Idea and Vodafone.
Yeah, that has created by me. Now OpenShift image registry is actually running inside a container or inside a pod, and see, this is the cluster image registry, node CA, a lot of things are there actually. Okay. Now
these are the images, is it?
Yeah, these are the pods actually, which is running inside the project. Okay. Project is a namespace.
Okay. The name of the project is name of the project is Open Image Registry. Okay.
Yeah, name of the project is OpenShift Image Registry. If you want to switch into it, OpenShift project, OpenShift Image Registry. Now you can run all command, OC get, SVC, OC get all, everything you can run. Okay, once you have like migrated to a project, you do not need to run or write -n again and again. So that is a new facility in Kubernetes. You always need to give kubectl get all -n grass, -n grass 1. Every time you need to give it if you are not setting up the context. But in OpenShift, right now, in which project you are, you can see it by OC project. Right now you are using OpenShift image registry. If you want to switch to project, OC project, I want to go inside Idea project. Now you can run OC get pods. If I want to go inside the OpenShift authentication project, I can use OC project, OpenShift authentication, OC get pods. I do not need to give -n again and again. Okay, I can switch to projects.
In Kubernetes, a general command, and in OpenShift we log into specific project and run our normal OpenShift
commands. Yeah. Now, like the way you do in Kubernetes, kubectl logs, so OC logs, tail 3, I want to see last 3 lines. In which namespace you want
kubectl, sorry, in Kubernetes we are not get the isolation as a from the user perspective, right? Project perspective. But in OpenShift we are getting isolation as a project.
In Kubernetes you can do that by setting up the context. Okay.
Okay.
Like by default, if you will run this kubectl get pod command, from where, in which namespace it will show you the pods, the default namespace.
Right.
So you can set the default namespace again and again. Okay. But that would be typical. In OpenShift, it is easy actually.
Customized basically, right?
Yeah. Now, if you want to see the logs, you can see the logs like this. Now see, right now I want to see the logs of a pod and the name of the pod is this. It will not show me. Why? Because this pod is actually having two containers. So I can use -c to mention the name of the container inside the pod because the pod do not have any logs. The container is running the application inside it. So the container is generating the logs. So if a pod is having two containers, you need to mention the name of the container. Okay, to get the logs. After that, OC logs, see OpenShift image registry. Now this image registry is only having one container. So it is directly giving you the logs. Okay, it is the name of the pod. Now, OCADM node logs. Now this is a very beautiful command. In Kubernetes, you cannot see the node logs from the master, but in OpenShift, you have the facility. You can run this command. OCADM node logs, copy, paste. And I want to see the logs of kubelet. And the kubelet service logs I want to see, and on what server, master 01. It will give you the logs.
Kubelet is a pod. Pod is running on that node.
No. Kubelet is the agent actually. Okay, on that node.
Okay.
So it is actually giving you the node logs. Okay. Now, means from the master you can control it now. You do not need to go on the worker node. From master you can give the node logs command and you can give the worker node name. It will automatically show you the logs of that service, kubelet. Okay, that is stopping, kubelet service, consuming, everything.
Can you list out the services where this kubelet is mentioned? Can you list out?
Yeah, kubelet.service.
No, where we have mentioned that -u is equal to kubelet, right?
Here.
So, but from if I want to see some other options of -u, what is that option?
Controller.
Want to see some other logs? What happened to this now? You can use it for a cry-ctl service.
That I'm saying, but can I see the list of that all the services?
No, that is not possible. There is no command to see that actually. Okay.
Okay. So,
yeah, kubelet and the cry-ctl is given in the book. Okay, so we can use that, but we can try. Like if I want to see the logs for the only node directly, master 01, that will show me the basic general CTL logs over here. Okay. If you want to see this log for the Docker or let's say for the cron job service like cron d -u cron d, we can try that. It is not giving you any logs. Okay. And maybe in the help you will see the options. So -u unit return log entries from a specified unit only applies to node general logs. Okay. So you can write the unit name. You can try for cronid. It is giving you the logs for cronid. Okay, so you can write the service name. Okay, Manish.
Okay, so
cronid, SSHD, HTTPD.
Okay.
Okay, HTTP is not running right now. Kubelet is also the service.
Network. Can we show the network services on that particular?
Tell me the name of the service.
Know the name. Network. Running.
Generally, if you want to see the status of service, you run this command, systemctl status.
Correct.
Tell me the name of that service which you want to see the logs of.
Network manager.
Giving you?
Okay.
Now, After that, OC debug node. Now this is a command you can log in inside a node actually from the master node. This is a very beautiful feature of OpenShift actually. Let's say in Kubernetes, Manish or Ashish or Nagi, if you want to go on the worker node, how will you go? Will you do SSH? Am I right?
Yes, correct.
But OpenShift has a power that it is not giving you the facility to SSH on the worker node. You cannot SSH on the worker node if you have installed the OpenShift cluster with full stack automation. This feature is removed, okay, from by Red Hat. Now, if you want to log in inside the node, then you have the debug command. A very beautiful command. You do not have this in the Kubernetes actually. I want to log in onto the node master 01 and I want to create a directory over there. So OC debug. And after that, I can run chroot host. Now I can do anything. ls, this is the data of the worker node. Cat etc passwd, this is the command which is actually executing on the master 01. See, only two users are there. I want to create a directory on the worker node. I can create. I can see the host name. See, there is no such.
One minute. So we are logging into the master node. It's login then
From workstation.
From workstation.
We have not done SSH actually.
So the same, okay. In production as well, we are one VM as a workstation. So we from workstation we will do all the things, right? Or
Yeah,
login.
that workstation can be any laptop, any system in the world. Okay. Now, exit. If you want to go on master 2, you can write master 2 and this command it is giving you to run. 2. Now you can run host name. Master 2 is the host name. Exit. So OpenShift does not allow you to SSH on the worker nodes in 4.5. Okay. You have to.
Okay. So my query is that in the OpenShift architecture, the workstation is a must, is a part of that, just like a KVM server to deploy the things, right?
Yes.
So that from that workstation, we can access all the nodes, even master and worker node directly, right?
Directly.
Without doing any SSH.
Yes. Obviously, we have done the OC login command now. This command we have run now, OC login you kubeadmin. Where you want to log in? What is the API server? This is the API server. Okay.
We have sourcing the
source means only to activate this variable actually.
Right. Sourcing that particular user my credential of kubeadm, right?
Yes, you can give the password directly also. Okay. Yeah. Now you can run systemctl status kubelat, systemctl status cryo. These all commands are actually being executed on the master 01. Okay. Now cryctl ps -- name open vswitch. Okay, so cryctl is the docker command actually. Instead of docker, if you are using cryo, you can use cryctl. Cryctl ps, cryctl run, cryctl build, cryctl tag, all the commands are same. -- name open switch means I want to see all the pods or the containers which are named as open switch. That's it. Now of C project, now execute troubleshoot. One troubleshoot option it is giving you right now over here. So I am going inside execute troubleshoot. Now see, before that we can cover the chapter first. Okay, this was the initial setup you have to do. So now we can come on the chapter again. Yeah. Reviewing the cluster version resource. Okay, so it's something like to log in into the cluster, start by exporting the kube config variable. whose value points to the auth kube config file in the installation directory. And the OC command uses this environment variable to locate the API endpoint of the cluster. So instead of writing the API URL over here, you can store it into the file and you can call it. Okay. And OC login -u kubeadmin -p, and you can give the password. That's it. So we do not need to set up that. Okay. We can directly give the API server URL. If you don't want to give, you can run this command. And inside this file, you can add this address. Okay. So not that much important it is. Now, OC get cluster version. You can see the cluster version by using this command. Right now, the cluster version is 4.5.4. Okay. Now, after that, OC describe cluster version. And let me do ls with it. See, the cluster version is right now, the cluster version is 4.5.5. Yeah. And it is the part of the stable channel. We will understand about the channels also in the 8th chapter. There are 3 channels, the stable, fast and candidate. In the stable channel, actually, you will always get the OpenShift version, which is stable from Red Hat. So we will discuss about it in the 8th chapter. So right now it is stable 4.5. And the version is 4.5.17, which is the available update. Okay, you can update it. Right now we do not have any privileges to update this cluster because this is a Red Hat pre-installed cluster. Now, so stable 4.5 available updates it will give you. Okay, cluster ID, upstream, lot of things are there. Now, reviewing cluster operators, OC get cluster operator. With this command, you can see all the operators which are available inside your cluster. If some operator is not available, you can download it. Okay. These are the operators. For storage, they have given the operator. For network, they have given the operator. For monitoring, they have given the operator. For machine config, approver, a lot of different type of operators are there. Authentication, we generally use. Okay, in the authentication operator, we use OAuth, which is a cluster operator. Now, which is a custom resource actually. Okay. Image registry is also running inside an operator. etcd console. Now, version available or not right now. Progressing, if there is something like progressing true means that is under development, not completely developed. Degraded false means it is not degraded. Okay, and since 3 hours 58 minutes it is present inside your system. This information is given over here. Now, displaying the logs of OpenShift node that we have already used. OCADM node logs -u cryo kubelat OCADM node logs, my node name. It will show you the general logs of the node, means it will execute the general CTL commands on the worker node. Opening a shell prompt of an OpenShift node. So we have OC debug command that we have used, and you can directly run systemctl is active kubelet. Do not need to SSH on the worker node. Now, troubleshooting the container engine means if I want to see how many containers are running cryctl ps. Okay, this is the command. We can run that. OC debug. Node master 03 I want to go on chroot/host and cryctl ps. These containers are running less. So these are the containers which are running. Okay, state, name, pod ID, everything. Clear? You cannot run docker ps, I think. It is not found command. Podman ps, there is no container. Because see, if you are creating a container with cryo, Podman cannot see it. If you are creating a container with Podman, cryo cannot see it. So you cannot use podman command for the task because it does not have visibility on the containers created by Cryo. So that is the approach, but podman is available. Okay, podman images.
Repeat that line, that Cryo and this podman.
If you are creating a container with Cryo, then podman cannot see those containers.
Okay. And vice versa.
Vice versa. See, these are the images which are available. CryCTL images. It is also showing you the images. Okay. Now, let me exit from it.
Can you show how many images we have in our local registry, or it will directly fetching all the thing from the in this test setup is taking from the online? Is it?
Generally, if you are using some new image, then it can download from docker.io also. Like if you want to pull some image, then you can pull some images.
Can we see that how many images is there in local registry?
In your local registry, how many images are there?
Right. OC get
That
image.
you can see by using this command, podman images, and you can count all the repositories which are available locally.
No, just hold on. So you are saying that we need to log in into master, right? From this is we are sourcing the master. So in master we are running a command. OC.
Yes, chroot/host.
Right.
How to see all the images? Podman images.
Yes, podman images.
WC-L. Right now you have 64 images present on the master 3. Okay.
Right.
Now, troubleshooting application deployment. So if you want to troubleshoot pods that start, then you have some commands. We will look these commands also, like OC get pod, OC status is there. Okay. And error image pull means the image is not getting pulled, image pullback off. You can describe the pod. These all are the same commands. kubectl get pod, kubectl status is not
error image pull, or what does this mean?
Error image pull means there must be some error in the deployment. Maybe you have given the wrong path of the image. Okay. Yeah. Let's say I'm writing TB Kushal. If there is no image which is available on the name which I am giving, then obviously it will give you some error like error image pull or image pull back off.
Okay.
Yeah. Now, same kubectl get events, OC get events, same commands. OC status command is also there to see the status of a project, like OC status. Right now, one service is running, one deployment is running on for 31 minutes, and there is no pod. Okay, so this is a very basic status. You can run OC get all to see the complete thing. You can run OC get EV to see the events. Okay, same command we have used in Kubernetes. Now, troubleshooting running and the terminated pod. So OC logs you can see. OC logs pod name -c container name. This is also the same command in Kubernetes. kubectl logs pod name, and for what container you want to see logs, you can use -c option. Okay. Introducing OpenShift aggregated logging. So Red Hat OpenShift Container Platform 4 provides the cluster logging subsystem based on Elasticsearch, Fluentd and RSysLog and Kibana, which aggregates logs from the cluster and its containers. And deploying and configuring the OpenShift cluster logging subsystem through its operator is beyond the scope of this course. Okay. So you can refer to reference section at the end of the section.
Can we see all the logs of any one of the default pod created by the OpenShift?
Yeah. OC get pods -n. Let me change to a project. OC project OpenShift.
Right.
Image registry OC get pods. Now this particular pod is having 2 containers. This pod having 1 container, so I can directly write the name OC logs.
My image.
Giving you the containers logs. Okay.
There are two
If you have two pods, then you first need to describe it. OC
get
describe pod and what is the name of the container inside it? Grab container. Okay. I need to search it. Just a second. Yeah. Here.
There is no other way to see what exactly container is running in that. That is container.
You have the way. This is the first container.
Yes, container image
This
registry.
is the second container. No.
Not any other way to only describe is option, right?
Yes. After that, you can grab. And
Okay,
I think one more option is there. OC get pods -o white. It will not also show you the containers. -- show labels also will not show you. No, there is no option. Okay. Now,
either we need to extract the YAML or scat it, something like that, right? Only that one option.
You can use less. So it will give you over here containers. How many containers are there?
Correct.
One is the cluster image registry. If you want to see the logs of it, you can copy it.
Right.
See logs.
Also get log, then pod name. Dash container dash. Got it.
After that, creating troubleshooting pods. So you can create some troubleshoot pods also. OC debug deployment, my deployment name as root. This command we will be discussing later. Okay. Now, changing means in the exercise. Changing a running container. If you want to log in inside a pod, you can use RSH. This is a very beautiful command which is given by OpenShift. OC get pods. If you want to log in into any container, you can directly use OC RSH. Do not need to write OC exec -it container name bash. Everything was removed.
RSH is equivalent to exec, right? Something.
Yes, it will directly give you SSH.
These are the all the okay. This is the temporary folder.
OCCP. If you want to copy some data from base machine to container, and OC port forward command is also there. Okay. OC port forward command is generally used to forward a port on the host machine to the pod directly. Okay. Let's say
that is the same use case we learned in the Docker, right?
Or, yes, same use case. But the problem of this command is if you are running this command, until the command is actually running, the port forward is active. Once you are stopped the command, the port forward will be closed. Okay. So this tunnel is only alive as long as you keep the OC port forward command is running. Got it?
No. Come again. What is the it mean running?
Running means that if you let's say if you are running OC port forward command, my pod name, local port and remote port, the command will actually eat your shell. Okay, it will be keep running on the shell. Got it? Now until it's running, the port forwarding is active.
Can we see the example?
Yeah, we will see the example in the labs, Manish. Okay. One example will come in the labs where you will forward a port for MySQL of 3306 to 3306. Okay, where we will discuss this. Clear? Now, troubleshooting OpenShift CLI commands. So you can use -- log level 6 to have multiple logs, lot of logs. Maximum is log level 10. This is a general Linux thing. Okay. OC whoami -t to see the token which is provided to user. Whenever you are actually logging from the workstation to any API server of the master, the API server always gives you a token which is valid for 24 hours. Okay. If you want to see that token, you can use -t. So this is the token which is provided to you. Okay. Now, one lab we need to do over here. This we have done. We need to do from here. Yeah, OC project execute troubleshoot. One more thing, guys, I will not be doing all the labs by myself. Okay, you need to do these labs by yourself on your role actually. Okay.
Yes, Krishna. Yes, Krishna.
OC get pod. Now see, this is having this error, image pullback off. How will I know that what error it is, why it is giving you? First, I will go for events, right? In the events, if you will check, then you will see that failed to pull image. And what is the name? registry.access.redhat.com RHSCL PostgreSQ. Okay, this is the image. So now I can copy this image as it is. Okay, Control C. Maybe this image is not available or I have given the wrong name. With the help of Scopio, I can inspect this image. Scopio is a Red Hat tool which is given instead of Docker so that you can inspect the images. Now see, there is no image like this. Maybe there can be a SQL error parsing. Okay, I need to give some options also like Docker. Let me see the command. Yeah, I need to give Docker actually. Image is available. Okay, it is inspecting, but if you are using the previous path SQ, then see, there is no such image. So obviously there is some error. Now what can I do? I can edit the deployment. I can change the name of an image over here. This is the image name. I can make it PostgreSQL. OC get pods. The container is getting created. Running. Now you can delete the pod which is not running. Delete pod. Same way we do troubleshooting in Kubernetes. Okay, a very simple error it is. It has inspected, added the deployment, changed the name, OC status, and OC get pods running. And lab execute finish. Once you are done with the lab, always run this command. Done. Now. Okay, this we will do on Monday, authentication. Okay.
My one or two questions for you, Kaushal.
Yeah, say.
First thing, can you open the GUI for that? Is it possible?
GUI?
OpenShift GUI. Console. You can see that
web console.
Yes.
Yes.
For that, I need to check it is activated or not. They have, I think they provide the details right now, but over here they have not given any details. Okay, one command I have, I think OC, double tap, convert CP console, cluster info. Master is running at this to further Ruko. One command is there. I think they have mentioned in the starting of the book how to access the console. Console URL of OpenShift. Maybe the web console facility is available or not, I don't know, but we can check that. OC get projects grab web console. There is no project like web console. Okay, there is OpenShift console project. We can go inside it. OC get pods. Okay, running. Now OC get all. There must be some URL. This is the route. So this is the OpenShift console. Now that cannot be accessible from here. That can be accessible over here. Firefox. Copy. This is the console URL. Oh, no. Just a second, guys. Huh? Say. क्या अभी तो कैसे करूं कल का बताता हूं कल बताता हूं सेंड करता हूं थोड़ी देर से है ना वेयर इज द टर्मिनल कॉपी या username invalid username and password admin this is how you can access the console Manish but right now I don't know the username and password Red Hat has not given any username
I
and
think
password
cube
in
admin, cube admin and Red Hat password is cube admin and Red Hat.
we can try that cube admin Red Hat no admin Red Hat no maybe they have given the password in the console cat usr local etc ocp4.config master api wildcard adm password user password is Red Hat and let me do one thing oc get pod oc describe okay oc get all service deployment replica set route okay oc describe deployment console less maybe they have given the password over here label service account console is over here out bridge bin bridge where console config.yaml service crt file http cat pirate extracted I think it has a lab for the console managing web services Yera. Red Hat console is graphical user interface yeah administrator and for the courses guided exercise we can see we need to run lab console admin start now it will be creating the username and password okay admin leader developer admin Red Hat show console and after that admin with Red Hat now it will be accessible started. Cube admin.
लोकल यूजर के अंदर है तो लोकल के
लोकल
अंदर
यूजर कुशल कुशल ये किसका लोकल यूजर
Okay, finally, this is the console.
okay.
Workloads,
Go to
everything
the
you can.
deployment. Go to the deployment. What is deployment and deployment conflict? Difference क्या है इसमें? ये पढ़ेंगे हम.
What you are
देखो.
saying?
Go to the
Deployment
workload.
config was the concept of OpenShift 3.9. Okay.
In the workload. Go to the workload.
Yeah. One is deployment and one is deployment config. Okay. There are two type of term. Now, right now there is no deployment config. Okay. But all OpenShift 4.5 is actually depend on the deployment. Okay. It is just given to you. Okay. It was the feature of 3.9. Okay. We do not use DC in the 4.5. We always use a deployment.
Okay. Right.
There are some, I think, annotation differences. Otherwise, these are completely same. Okay.
And one thing more, second question after that is, can you see, can you open that in master config file in the CLI where the deployment will happen as a master config file or environment file, we can say that.
No, what again? Come again.
Go to the in the master while deploying the OpenShift, what exactly IP we set in the IP pool we set for that container.
This is a full stack automation installation. Okay. If you want the all the locations of the files, Manish, you can read this documentation. Okay. All the locations of the files are actually present over here. Okay. We can search that. Master config file in OpenShift master node. Yeah. It is the etc origin node config.yaml. Okay. We can see that.
This is not a origin, right? Is it origin?
It is not origin, it is enterprise, but
okay, let's try.
4.5 master config file in OpenShift 4.5.
ये 3.11 ही दिखा रहा है अभी भी.
ये तो Red Hat का डॉक्यूमेंटेशन है. Worst. Accessing host, DNS operator, PTP hardware policies. Master configuration file, what is the location? I can do one thing, OC debug master. Must be in ETC. There is no such configuration file, Manish, present because it is named as master-config.yaml, but it is not present over here. T star, there is no file like that.
Okay, let we discuss in the later. No problem. And is there any?
There is no file actually. I'm saying that there is no file.
Okay, I think I have seen this in 3.9, so maybe that has changed.
3.9, the location is etc origin.
Yes, right.
Master/master-config.yaml. In that you can set all the parameters and everything actually.
Right.
But inside the Kubernetes, and why there is no file, let me tell you the reason. You have the projects related to the networking, which is managing the networking. Network star. Now you can go inside it. OC get OpenShift hyphen network operator. To this, I need to write the name. What happened to this? OC get projects. There is a project which is active. Why I'm not able to go inside it? OC, okay. Now, OC get all. Manish, you can describe this deployment to see the network details, okay?
Okay.
Because everything is managed by this operator. Clear? So there is no such individual master configuration file. Clear?
Got it. And Kaushal, so is there any not any other way to deploy 4.5 on my local laptop, right?
If you have 16 GB of 3 machines and if you have the Red Hat subscription, standard subscription, then you can deploy.
I understand.
Okay. But you can install OKD 4.5. But I tried to install OKD 4.5, but there are a lot of bugs and errors actually. And it will waste your almost 15 to 20 hours. So there is no need to go for OpenShift OKD 4.5. You can go with CRC and you can practice the stuffs over there. Okay.
So ये 90 days means when you start that immediately 90 days start, right?
Yes, 90 days 80 hours आप lab use कर सकते हो, उसके बाद नहीं.
80 hours and 90 days.
Yes.
तो
अभी हमने दिन के 10 घंटे कर ली तो 10 दिन कर पाओगे, सिर्फ 8 दिन कर पाओगे. 80 घंटे कंप्लीट करने कैसे भी इन 90 डेज. अब आप 2 दिन में करो, 5 दिन में करो, डिपेंड्स ऑन यू.
वही तो पंगा है. अभी कर लेंगे तो फिर प्रैक्टिस कैसे करेंगे? दैट इज अ चैलेंज.
लेकिन मनीष
आप जब रूल एक्टिवेट आपका हो जाएगा, यू विल सी दिस टाइप ऑफ आइकन. ओके, इस टाइप का आइकन आएगा आपके पास. आप वहां से वीडियो क्लासरूम ऑन कर लेना. मैं बता दूंगा वैसे ये जब एक्टिवेट हो जाएगा. ये तो फुल ऑन एक्सेस है, इसमें रेड हैट के सारे कोर्सेज हैं.
Ashish, you are saying something?